Hello, welcome to Schools Not Out, your daily classroom for CSEC and CAPE students. You can watch this lesson real-time on Television Jamaica's YouTube channel or on onespotmedia.com. We are also live on Music 99 and gojamaica.com. If you have questions on today's subject, CSEC Math, you can send them in to Television Jamaica's Facebook page or Instagram at television_Jamaica. Today's lesson is multiplication of matrices. I am Karema Mundel-Thomas.
And I am Tamika Lodge Fenton.
So, Tamika, we're looking at multiplication of matrices, and I think that, this is a quite interesting topic, but also one that sometimes tend to be problematic for our students. So I'm happy that we're given the chance to explore this today. So in our session today, we're going to be looking at how to use matrices to represent real-life situations. We're going to learn how to multiply matrices, use the order of matrices to test their compatibility for multiplication. And of course, we will be able to identify the 2x2 identity matrix for multiplication. But first, let's recall a few things.
Most definitely. So what is a matrix? A matrix is simply a set of numbers or terms arranged in a rectangular array. Matrices are used to solve problems in electronics, robotics, linear programming, intersection of planes, and genetics. The order or dimension of a matrix is given as the number of rows by the number of columns. So we have number of rows by number of columns.
And we would have done something like that before.
We would.
Yes, we would.
So let's look at this the diagram we have there. We have matrix A, and as you can see by the arrows and the annotation, it has 2 rows, 3 columns.
And we want to remind our students that the rows are horizontal, right? And our columns are vertical. Very important, especially as we go into this particular topic. All right, so we can say that the order or dimension of matrix A is
a 2x3.
That's right. So Tamika, can you state the location of the element 6 in matrix A?
Well, now that I know that the matrix has rows and columns, 6 is in the first row.
Okay.
And it is in the 3rd column.
Ah, you sound like a brilliant student. So the element 6 is located in row 1.
Column 3.
Column 3. So let's get into today's lesson.
Most definitely.
So Tamika, you're organizing a netball championship.
Yep.
Right?
I'm on top of this.
That's right. So you're not a coach now, you're an organizer.
That's right.
In your championship, 3 points are awarded for each win, 1 point for each draw, and 0 points for each loss.
Look at that.
Now, the table is showing the results for matches that were played by 4 teams. So we have here Team J, Team K, Team L,
and M.
And we can see from the table how many wins. So if we look at Team J, they won 4 matches.
Right.
Yeah. They had a draw for 2 of their games.
Right.
And they lost 2. And we can follow again.
And
Team K, 5 wins, 2 draws, 1 loss. And of course, Team L, they won.
So good in the winning.
Yeah, not so good. But they kind of make up a little.
They draw 4.
Yeah. But they lost 3 matches. Now M having a rough time.
Them no win,
no
not
wins.
at all.
Oh. So they lost 2 matches. No, yes, they lost 2 matches.
And draw 6.
And they drew 6 matches. So the question is, how many points does each team earn? So at this point, we're checking to see, because when we have championship, we want to decide which team moves on to the next round, and we need to check the points.
Right.
So how could we find out how many points each of these teams earned? So,
well, you did tell us that if you win, you get 3 points, draw 1 point, and if you lose, 0 point, which is understandable.
Yes.
So let's figure out how many points would Team J, K, L, and M gain after all these matches.
Well, let's check. Well, we see here that Team J won 3 matches.
Well, 4.
4.
Right.
Can you believe I pointed at 4 and
I
said
saw.
3?
I saw.
My goodness.
It happens.
No. so Team J won 4 matches, and they are going to be getting 3 points
for every match that they win.
That sounds like 12 points to me.
That's right.
All right. So they would have had a draw for 2 of their matches.
And they get 1 point for every draw match.
So that sounds like 2 more points.
That sounds right.
On the
so
12
that's
that
12 and 2 that we reach 14 so far.
Let's check.
And they get 0 for losing. So.
And we know 0 times 2 is 0.
Exactly.
Poor
so
thing. So they
J
had 14
is at
points.
14 points.
All right, makes sense. So let's look at K.
So K would have won 5 matches.
Right.
So it's 5.
And we're using the
for
points.
3.
So the 3 points for each of the matches.
So that would be
all right.
15 there.
Right. 1 point.
They drew 2 matches. So that would be 2 more points. So that's 17 points in total.
That's right.
Okay, L.
Let's check L.
They won only 1 match, giving them 3 points. They drew 4. 4 gives them
so 1 times 4 give them 4.
Exactly.
And no points for losing. So they have 7 points.
7 points in total.
Beautiful.
Well, they won nothing, so that's 0 there.
Yes.
They drew 6 of their matches and 1 point for each. 6, so it's 1 times 6 is 6. So 6 points.
It is.
K is top in this competition, man.
Yes, looking at it, K is at the top of this table.
Yes.
That's what they say in these matches, at the top of the table.
Top of the table.
Yes, sounds familiar.
Yes.
All right, so, but you know, Tam, this...
Does this look like anything we would normally do in our math classes?
Yes, something in it is just clicking in my head.
Yeah, man, it resembles something that we do in math.
Wait, name
I wonder if the students are seeing it.
I wonder.
They should, because we gave them some hint when we started the topic.
That's right, we did. So we're looking at matrices, and this does resemble matrices.
It does. You see that rectangular array of numbers?
Yes. You know, I'm wondering if we could actually put this information, it's in a table now.
So we're going to put it in a way that you're more familiar with.
Yeah.
When you look at this, you will see a more familiar representation.
That's right.
Okay.
So let's check. So we can represent the match points for winning, drawing, and losing in a matrix.
Most definitely.
All right. So let's see what that matrix looks like.
So we have 3, 1, 0.
So this looks like it's a 1 by 3
column.
All right. So we have a 1 by 3. Let's look at the next one. We can also represent the match results in a matrix. Let's see what that matrix looks like.
So remember the rows are horizontal.
That's right.
So we have 1, 2, 3 rows, and the columns are vertical. We have 1, 2, 3, 4 columns.
Right.
So that's a 3 by
4 matrix. Right. So it sounds like something that we can work with. You know, I think we're coming up on a break.
Yes, we are.
And it's so appropriate because we're right at this point. We will take it up from here when we return from this break. So more on Schools Not Out right after the break. If you forgot to take up your book and your pencil and your pen, now is a good time to take it up, all right? And remember, in the break, of course, wash your hands. Sanitization is the key.
Social distancing.
That's right. We'll be back shortly.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with a cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with the cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
The Ministry of Education, Youth and Information, along with TVJ, present Schools Not Out, CSEC and CAPE lessons live Mondays to Fridays from 9 a.m. to 12 noon, with weekly Schools Not Out tutorial sessions on Saturdays from 1 p.m. to 4 p.m. Schools Not Out, live CSEC and CAPE lessons here on TVJ.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with the cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
The Ministry of Education, Youth and Information, along with TVJ, present Schools Not Out, CSEC and CAPE lessons live Mondays to Fridays from 9 a.m. to 12 noon, with weekly Schools Not Out tutorial sessions on Saturdays from 1 p.m. to 4 p.m. Schools Not Out, live CSEC and CAPE lessons here on TVJ.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with the cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
COVID-19 tip. Protect yourself and others from getting sick by washing your hands after coughing or sneezing, when caring for the sick, before, during, and after you prepare food, before eating, after toilet use, when hands are visibly dirty, and after handling animals or animal waste.
The Ministry of Education, Youth and Information, along with TVJ, present Schools Not Out, CSEC and CAPE lessons live Mondays to Fridays from 9 a.m. to 12 noon, with weekly Schools Not Out tutorial sessions on Saturdays from 1 p.m. to 4 p.m. Schools Not Out, live CSEC and CAPE lessons here on TVJ.
Reduce your risk of viral illnesses like the flu and coronavirus. Wash your hands frequently with soap and water. Cover your nose and mouth when coughing with a tissue and dispose of it. Avoid close contact with anyone with the cold or flu-like symptoms. If you become ill, please visit your doctor or the nearest health center and share your travel history. The flu and coronavirus can kill. Let's protect each other. A message from the Ministry of Health and Wellness.
COVID-19 tip.
Welcome back to Schools Not Out, your daily classroom for CSEC and CAPE subjects. Today we have been discussing
CSEC math.
CSEC math.
That's right.
And the topic we're looking at is?
Multiplication of matrices.
Matrices.
That's right. All right, so Tam, we were at this point where we have our matrix. So we have a situation where we're looking at a netball match.
Right.
And we have...
Well, the championship.
The championship,
right.
That's right. Did I say match?
Yeah.
Oh, there. So we're looking here at the matrix for the match points.
Right.
Yes, and we're saying that it is a 1/3 matrix.
Right.
All right. And here we have the matrix representing the results from the matches for J, K, L, and M. And we're seeing here that it is a 3/4 matrix. And we're at this point now going to see how could we multiply these matrices. So we have matrix A, we have matrix B, and we're going to be multiplying. Now, if my memory serves me right, I think when I was learning this in high school, many moons ago.
Yeah, let's not go there.
It was row by column, row by column. So, row in the first matrix
multiplied by the
column in the second matrix. All right, so let's see if we can help our students here, Tam.
Okay.
So again, the reminder is popping up. Remember, it is rows in the first matrix, multiply the columns in the second matrix. So I'm seeing here 3
multiplied by the 4.
Multiplied by 4. So the first term in my row here, multiplying the first term in my column. Beautiful. And 3 4s? 12. All right. Then we move on. 1 here now is multiplying
by the second term in the same column.
All right, so we're looking at second term in this row, which is row 1, because we don't have any other row anyway.
Exactly.
So in row 1, the second term is now multiplying the second term in column 1. All right, and that would give us 2. And then 0 is now multiplying by 2.
The 2.
So I have the third term
multiplied by the
in the row. Multiplying the third term
in the first column.
Beautiful. All right. So I think our students can now follow us.
Right.
As
so we
continue.
Can just pretty much go through.
All right. So it's 3 times 5. 15. All right. Follow us now. Don't get lost. 1 times 2. 2. And of course, 0 times 1. 0. All right. 3 times 1, 3. 1 times 4, 4. 0 times 3, 0. And that's pretty much the same thing that we're doing. So if we notice, we're using this one row to multiply every single column. So we're doing each column, all right? So we are now at our final column now. So 3 will multiply 0. 1 will multiply 6, which gives us 6.
And 0 will multiply 2.
That's correct. And that will give us 0. All right. And so we can basically now add up, or add these values.
Right.
And we have our resulting matrix, which has 14, 17, 7, and 6. And these numbers sound familiar.
Right, because if we remember the table that we're looking at, J would have gotten 14 points, K would have gotten 17 points because they were on top of the board. 7 would have gotten 7 points. 7 would have gotten 7 points.
Would have gotten 7 points.
And M got the least, and they got 6 points.
But, you know, I want to point out something here, because one of the things that I think, you know, our students struggle sometimes with is, where do we put the values
that they get from multiplying?
Where do they put these values? And so, you know, it is so important that we look at the location of the results.
Right.
So I'm going to take it back from here. If we notice, when we're looking at row 1, so we'd have used the elements in row 1.
Right.
And we would have used them to multiply the elements in
column 1.
Notice the results
is row 1, column 1.
So all those results have to go
where column 1, the position.
So students who are having any issues with, you know, where to put your answers, this can be a guide to you as to what to do. So let's look at the second one. So we have still row 1.
I know we're looking at column 2.
Beautiful. And the results
those results go in row 1, column 2.
And we pretty much follow
Right.
that same trend, all right? We will get to explore this a little bit more when we go further into the lesson. So just a quick reminder, I would have said it, but I know that there are persons who are visual and so they need to see it written.
Right.
It says, notice the location of the row being used from the first matrix and the location of the column being used in the second matrix determine the location of the result. So if row 1 is multiplying column 1, the result will be in row 1,
column 1.
column 1. Now,
let's take a look at the order dimension of these matrices.
All right, so let's take a look. So these were the matrices that we were multiplying earlier.
Right.
And that was the result.
Correct.
So we would have made mention from before that our first matrix is a 1 by 3
matrix.
Right, and our second matrix is a
3 by 4 matrix.
3 by 4. And the resulting matrix is a?
It looks like 1 by 4 matrix.
I wonder if there is a connection
with the
this
two matrices we used to multiply with the,
and the order
result.
of the results. I wonder if there's a connection between this
that one
and
that
this 4. Yeah. But you know, as mathematicians, we don't take one thing
no, we have to go
and make a rule.
Do it a couple times
so
and see
we're
what
going to have
happens.
to test it a little bit more. But something interesting to note. So,
what would have happened if we interchanged the position of the matrices being multiplied?
very important question.
What do you think would happen, Karema?
Boy, Tom, this one look like it ought to bowl me
So we had the
over.
1 by 3 first.
Yes.
And then we had the, what is that?
The 3 by 4 after. So now we're looking at
3
BA.
by 4.
Yes.
Right. Multiplied by the 1 by 3.
So multiplying. So we're changing the positions of the matrix. And so now B becomes the multiplier and A is the multiplicand.
There you
go.
go.
We want to see what would happen. Now,
All right.
based on what we would have said, we can probably try to explore it a little bit on the
All
board.
right, so-
Okay, go ahead.
So we have
4, 5, 1, 0.
5, 1, 0.
2, 2, 4, 6. 2, 1, 3, 2.
All right, so this is our B.
3, 1, 0.
All right. You had said something. You had said that we're multiplying the rows.
In the first matrix, right? And we're using it to multiply the columns.
All right.
In the second matrix.
You're also paying attention to the terms.
Yes.
All right. So let's see what happens.
All right. So you want to try? Go ahead and
All
try.
right. So this is our first row. So it's 4
So
multiply.
you want to circle off our row?
Yes.
So let's mark off our row for now.
And
that's the column. Beautiful.
All right. So 4 multiplied by 3. Right?
Yes.
And then I have a 5 here.
Yes.
5 multiplied by...
Oops.
Where's the rest of my column?
We don't have enough elements.
So what do I do?
We have a problem.
This can't work.
Can't work.
Can't work.
Can't work at all.
No.
Oh my. So I'm getting from this term that if I have 1, 2, 3, 4 elements
in that row.
in my row here, I need to have 4 elements in my column
in order to make the multiplication
for it to be possible at all. Exactly. Makes sense.
It does. It does.
Yeah, I feel good. So we're noticing that row 1 in the first matrix has 4 elements, while column 1 in the second matrix
only has 1 element.
has only 1 element. There's a word that we use, to talk about compatibility.
They're not compatible.
Not compatible. People used to think that is only relationship.
Yeah, but in math, these matrices are not
they're
compatible.
not compatible to be multiplied in that arrangement. We can't just leave it and say they're not compatible, but
It's
in
true.
that arrangement,
Right.
because we would have used them earlier where we had
A first.
A being the multiplier,
Right.
and B being the multiplicand, and it worked.
It did.
So they are not compatible to be multiplied
In this
that
arrangement.
arrangement. So it means, therefore, that we can do some testing.
Right. So when you're multiplying matrices, you can test for compatibility.
Yes, they should have one of those for relationships.
A lot of things wouldn't happen.
Okay, so the number of elements, and this is interesting, and I want our students to really zoom in on this piece of information because it's very, very important. So the number of elements, Tam, in the rows of a matrix can be determined by examining the number of columns
in the same matrix.
In that same matrix.
Okay.
So I'm going to bring up an example, but
let's look
I
at
also
this.
want to look at
All
this
right.
one. So initially we had said that this is a 3
by 4. So what are you telling me?
All right, so based on what it says here, the number of elements in the row
So we have 3 rows.
is determined by how many elements, the number
examine the number of columns.
that will tell us how many elements. So if this is a 3 by 4, we're saying in each of these 3 rows
We have
4 terms
or 4 elements.
Elements.
Right.
Are we seeing that coming out in the matrix?
Well, if we look at this row, 1, 2, 3, 4.
Beautiful.
And if you look at
the
this
number
row,
of terms coincide with how many columns there were.
Most
not?
definitely.
So
Yes.
I think we're onto something here. So let's look at another example. So we're looking at a 2 by 3 matrix. Based on what we just said, we're saying this matrix has 2 rows, 3 columns. So in other words, we have 2 rows
with 3 elements in each row.
That's right. 3 elements in each row. Let's see if that matches what we're saying. All right. So 2 rows.
1, 2, 3 elements
in each row.
Correct.
All right. Great. Beautiful. So this 3 is important. 3 elements are in each row. So since we're doing row by column when we're multiplying it,
we need to pay attention.
That for that first matrix, I need to pay attention
to the number
this
of
number
elements
when I write the order.
Yes.
So if I have a 2 by 3 matrix as the multiplier, meaning it appears at the front,
right?
I need to pay attention to how
the number
many columns are there.
Yes.
Because it tells me how much term
is in each row.
Makes sense. All right. I hope they get that, because it's critical. Now let's look at this other part. The number of elements in the column term
of a matrix can be determined by examining the number of rows in that same matrix. So, you think they got it? Say it again. The number of elements in the columns of a matrix can be determined by examining the number of rows in the same matrix.
Yes. So let us look back at this 3 by 4 matrix. Yes, we would have said 3 by 4 matrix. So let us look back at this one and see if we can figure out what it is that they're saying on this slide.
So initially we were looking at the number of elements in the rows.
Yes.
So now we want to look at the number of elements in the column.
Right.
So we have 3, it's a 3 by 4 matrix.
Right.
It tells us that we have 3 rows.
Yes.
And we have 4 columns.
So since we're focusing
so within
now,
the column now,
we
have
3 terms.
3 elements or 3 terms.
Let's check if that really works.
All right, so we have 1, 2, 3, 4. Let's check. So the first column.
Yes. So mark it off. I can mark it.
All right, so this is our first column. And we have 1, 2, 3 elements.
Okay, so let's see if we can do that for this one.
All right, so we have this now. Let's name this matrix. So it is a 1
it's a 1 by
3
That's
matrix.
the order of that matrix. Good.
So we have 3 columns, and in each column, we have 1 term.
Ah, so I'm realizing the issue. So this 4 told me there were 4 terms in the row. We would have said that earlier.
Right, if we're looking at the rows, right?
Yes, and here, this is saying to me that there is only 1 term in the column. So that's why it never did work.
Can't work because we have 4 elements over here. And we only have 1 element over there.
That's why it wasn't working.
That's
so
right.
Let us check what's happening here. So of course we need a second example just to concretize this. So let's say we have a 2 by 3 matrix. Again, we're saying that for this matrix, it has 3 columns, but in each column,
it only has 2 terms.
It only has 2 terms. So my question to you, Tam, is if I had these matrices and I was going to multiply them a 2 by 3 and another 2 by 3, You think it could work?
Well, we did say that it is row multiplied by column. For the first matrix we have 2 rows, yes, but each of those rows have 3 elements.
Yes.
That means I'm going to need 3 elements in the column over there.
Yes.
But according to that, it tells me that it has 3 columns, but in each of those columns I only have 2 terms.
So we're 1 term short.
We're 1 term short.
Element short. Oh my
So
goodness.
it's not going to work.
Interesting stuff. I like this. So basically, these 2 matrices are not compatible to be multiplied with each other. All right, so we're moving on. We want to test now the compatibility. So let's see what's happening with these 2 matrices.
All right.
So we have a
2 by 1 and a 2 by 2.
You tell me, because you're the bright spark here, tell me, can we multiply these matrices
In this particular arrangement?
Yeah.
Let's see. Well, let's find out some things first. So for the first matrix we have 2 rows, and each of those rows have 1 element. So that means for my first row that I'm going to multiply, I have 1 element, and I would hope to
Which
have
is the
1
6.
element over there as well. However, the second matrix has 2 rows, and each of those rows have 2 elements.
Each column.
Each column.
We're looking at the column now.
Each column
So each of those columns
has
have
2
2 elements. So we have a problem.
Yeah, because I only have 1 element
so this 6
in my row.
Can't work for these 2 here.
No.
All right. So we can agree then.
So my row has
that-
less elements than my column.
All right. So these cannot be multiplied in that arrangement. Now I want to twist it a bit.
All right. So you've changed the position of the matrix.
Yes.
Of the
Yeah,
matrices.
I'm glad that you would have seen that it's the same matrices.
Yes.
All I've done is to switch the
Switch.
positions
Who
of
is the
matrix
multiplier and who's the
multiplicand,
Okay.
right? So let's see what we have here now. Oopsie.
Yes.
That's not what I wanted.
We gave a little clue.
Yes. So this is a 2 by 2.
Right.
And this is a 2
2
by
by
1.
1.
All right. And we would have looked at these numbers earlier, and we know that they have to be the
Right.
same so that we can actually have elements that can work with each other.
Right.
So we have
So the
2
elements in the first row.
2 elements in the first in the rows of the first matrix,
Right.
and we have 2 elements
In the column of the second matrix.
So we know that these can be multiplied in that arrangement. But here's my question to you. Can you state the order or the dimension of the resulting matrix? We kind of touch on something
we did,
earlier.
you know.
We saw something, but we say as mathematicians, we can't
You know, but
say something is a rule
until we try to
and just one example. Not true. Really can't say it on 2 either, but for the purposes of this,
Let us see.
We will see what's happening. So we would have earlier we would have noticed something with these 2 numbers out here.
Right.
So from what we saw earlier, we are assuming that the result of this matrix could be a 2 by 1.
Could be.
Could be. Let's check.
So
Nothing
it's
better than
negative
checking.
1, 5,
2
2, 3, 6, 7 for the
All right, and we said it's row by column.
So
All right,
we have
so negative 1 times
6 gives us negative 6.
All right,
And 5
and we're
times
still in row 1, still in the same column. So my answer must be right here with
row
my
1.
negative 6.
Right.
Row 1, column 1. So 5 times 7
is 35.
Okay, someone knows their timetable. So we are moving now to row 2, and we're using it to multiply column 1. So 2 times 6,
12
or 2 multiply
by 6
6.
gives us 12.
and 3 multiply 7.
Looks like 21.
Okay,
So we have negative 6 plus 35.
which gives us
29.
okay. You are on the ball. So we have 29 and 33. And what's the order of this matrix, Tam?
Well, it would look like we have 2 by 1.
It's a 2 by 1. Was that what we said?
A 2 by 1.
Beautiful. So we found several patterns coming out today.
Well, we did. We have.
So
working the few matrices that we have been working.
Yes. So we notice here that we can actually use the order of the matrix.
That we're multiplying.
And it gives us so much information.
Yes, it does.
One, it tells us if they are compatible to be multiplied in that arrangement.
Yes, and it gives us the
and
clue.
it also gives us a clue as to what the order of the resulting matrix
should look like.
So this result would be a 2 by 1. Interesting times. So let's move on. So we want to examine, we have matrix C, 1, 2, 3, 4, and matrix D,
8, 7, 6,
5. And we want to see if we're able to find the result of C, D. See, it's clicking.
Just come up, sir.
All right, so C, D. Now you would have noticed I have C in red, and you'll see why in a few minutes. So we have a 2 by 2 matrix multiplying another 2 by 2 matrix. Now, let's see if we can get some things going here. All right, so what are the terms, what are the elements that I'm going to be multiplying with each other? We said it's row by column. Now, this board space is a little small.
We can do one of them and then we can pick it up on the board.
And then we'll pick up on the slide.
Yes, most definitely.
So let's just do one on the board.
So we have, give me the first matrix
1,
again.
2, 3, 4. And 8, 7, 6, 5. All right. And it's row by column.
So it's row by column.
Right.
All right. So our first term, our first multiplication, 1 times 8 gives us.
So 1 will multiply 8, and that gives us 8.
And then 2
will multiply 6,
which gives us 12. All right. And then 1.
Why is there a comma here?
Oh,
it's
I'm
not
so
coordinate,
sorry. Oh, my goodness.
Yes.
And then we have 1
by 7.
By 7, which is 7.
And 2 will multiply 5, which will give us 10. Go to stick a pin. So remember we said when we did row 1, column 1, results go at row 1, column 1. Now we just did row 1, column 2. Results go where? Row 1, column 2. Beautiful.
So now we're at?
All right, row 2.
Row 2. Well.
And column 1 now. Let's do column 1 first.
So 3 multiplied by 8 gives us 18.
20.
Oh, Lord. You sure?
I'm just pick you up in about your timetable.
All right. All right, 4 times 6.
24 again.
Yes.
All right.
And then 3 times 7.
So 3 multiply 7 will give us 21. And 4 multiply 5 will give us 20. Again, note the position. Row 1, row 2, sorry. Column 1, row 2, column 1. Row 2, column 2. Row 2, column 2. So we need to make that.
So we'll combine our values. So that's 20.
17, 48, 41. Okay.
All right.
All right. So in the interest of space, so I want to take us back over here now. We would now look at DC.
So we have changed the position
of the matrix again. Right. So now matrix 8, 7, 6, 5 is the multiplier, and 1, 2, 3, 4 is the multiplicand. So we want to see, because we noticed that they are both 2 by 2s. So
the values are the same.
Yes, so we can actually find elements.
Compatible.
They are compatible.
Yes.
In this arrangement as well.
They are.
All right. So let's see. In the interest of space on the board and time, we would have done
some
of it. All right. 1. So again, row 1, column 1. And the results.
Row 1 by column 2. Results same position.
There.
Row 2, column 1. Yes.
And
row 2, column 2. Same there. Combine the results, combine the values.
We combine those.
Look at that, Karema. 29, 44, 21, 32.
Did we make a mistake?
I'm wondering. Did we add that properly? Did we do that calculation?
I think we did it fine.
We did.
Yes, but we're noticing something interesting here. Because
same 2 matrix.
Yes. All we did was to change the arrangement.
And we have our two resultant matrix is
2 by 2, but are
Two
the elements in the matrix,
they're not the same.
they're not the same. So what conclusion do you think we can draw, Tom?
Well, we can definitely say that multiplying CD is not the same as multiplying DC.
Well, we can certainly say that the results are not equal.
They are not.
And so we can conclude that matrices multiplication is not
Commutative.
That's a very important point. But you know, I wanted to ask, I know we have a little bit of time. This lesson is so interesting, time is just like running away. But I want to ask, because I noticed that this was a square matrix, a
Yes.
2 by 2.
And that was
this was
a
a square matrix.
right,
And we noticed
right.
that the order, though it gave us different results, we found that
elements-
they could be multiplied in either arrangement.
Right.
Is it only square matrix that
Let's
works
test that
for?
theory.
So put a 2 by 1 for me. And give me a 1 by 2. A 1 by 2. See, enough of my do it so big. Give me 2 little bracket, man. Picking up the space.
All right.
And I'd prefer if you
Not use
not
this?
give me a
All right
similar
then.
term from
All
me.
right. Let's
in
go
case
with
we're going to
4.
work it. Let's see
Good.
what's happening. So I want you to
let's
write
name
the,
the
right,
seats.
write the order for me. So that's a 2 by 1. And this is a 1 by. So based on what we would have learned earlier,
We can pay attention to the ordering.
all right, so we can look here and we can see that this multiplication is possible.
Yes,
they are
because
compatible in this
no.
arrangement. And we looked at the results.
So the result will give us a
2 by 2. These are not square matrix. So
No.
let's flip the order, the
all right.
arrangement.
So let's just change how we
Yes.
input it.
So
we
put the
have
4, 5.
4, 5.
That look like 45.
Yeah, that look like I just saw it.
Okay.
And then we have 2, 3.
All right. Please put the
All right,
order
so this is
of
our
the matrix.
1 by 2, and this is our 2 by 1. Look
So
at
I'm
that.
looking here. That's
So they're still compatible.
still compatible. But the
And-
result now is a 1 by 1
So they don't have to be square matrix.
to be able to be multiplied in different
multiplied.
order. But what we can say though is that the result
It's going to
won't
be
be the
different.
same.
Right.
Right, won't be the
So they
same.
will be compatible.
they may,
Outside, they may be compatible
may.
outside of a square matrix.
right, they may.
Okay.
They don't have to because
They
remember
don't.
our first example, right?
Right, you
so
are.
we have to point that out. All right, so let's practice multiplication of matrices. All right, so we are bringing up 2 matrices on the board. Not sure what's happening with my click. Nothing beats manual.
And we may have to come out of that.
So we have our matrix 1,
Okay.
0.
There we go. Oops. Let's just go back to the current slide.
All right,
Should
so
be
we have
fine.
our matrix 1, 0, 0, 1, and it's multiplying. We passed here already.
I know, right?
Passed
Okay,
here.
so we're gonna look at. Let's just use. Oh,
All right.
all right. Don't click. Let me see if we can just get through.
Okay, so we have a non-responsive.
So let's do.
It's running. It's running.
It's
All right,
coming.
so, yeah.
Okay, awesome.
All right, so here we go. Boy, this technology thing. All right, so we have a 1, 0, 0, 1. That's the first matrix, 1, 0, 0, 1. And the second matrix is -1, 5, 6, 3.
There you go.
So again, I want you to perform this multiplication on the board.
Okay.
And then we will compare with something that we have on the
All
slide.
right. So remember, it's your role.
So let's erase this section.
By column. And we would have been.
So we have now 1 times -1, which will give us
Negative
-1, 0 times 6, which will give us 0. All right, so let's come over to column 2. So 1 times 5, which is
gives us
5. 0 times 3, which is
Usually 0.
okay. Then let's go to row 2.
So we're in row
Column
2.
1.
Column
0
1.
times -1.
0
Yes, and 1 times 6.
is 6.
Beautiful. 0 times 5
Is 0
and 1 times 3.
is 3.
All right, so give me that resulting matrix.
And we
Tam.
would have -1. We would have 5.
I think you're missing an equal here since we're putting the results.
And this is 6. And this is 3. Am I right?
Yes, you are
Okay,
right. I'm just, I'm looking at it because I'm noticing that this...
looks the same as this.
Yes.
So what does it say about this?
Well, we would normally learn that whenever you multiply something
By its...
by the identity,
what happened?
identity, you get
The value is unchanged.
Yeah.
So the matrix remained.
So we can say then that this
Is there the
ident-
2 by 2 identity matrix for that 2 by 2 matrix?
for multiplication.
For multiplication.
Yeah, that's important.
There you go.
All right, so 1001 is the 2 by 2 identity matrix for multiplication. Important point. So I'm going to skim through because I want now to focus our viewers' attention on the other side of this slide. So as we have been exploring this morning, we're changing the
positions
yeah,
of
the
the
arrangement
multiplier and the...
multiplicand. So we're changing it again. So let's see what happens. So in the interest of time, I'm going to bring up the calculation on screen. All right, so
look at that.
we notice in
Matrix
this,
is unchanged.
but I thought that when we change the arrangement, we would get a different answer. Isn't that what we've been saying?
Well, you know, it looks like something special about that matrix there.
Something special about
that
the identity.
matrix look like it.
Yeah.
It's special.
It's special. It's
Yes.
special. As a matter of fact, it's the only time we can change the position or the arrangement
of the matrix.
Of the
matrices.
Yes, and we get the same
Result.
result. Special one, this
It
one.
is.
Yeah, this identity is quite special. All right, so the position of the 2 by 2 identity matrix did not affect
Change the results.
Very important. So, Tam, I think we would have learned a lot today.
I think so too.
So let's see if we can
Apply what we've learned so
apply
far.
what we've learned. We have a few minutes.
Sure.
So let's see how quickly we can do this. So we can't leave without a CSEC question. So L and N are two matrices where L is equal to 3, 2, 1, 4.
And N is
equal to -1, 3, 0, 2. And we're asked to evaluate L subtract,
N squared.
So, interesting. So first of all, evaluate.
They just mean work it out.
Oh,
give us a value.
Calculate. Oh,
yeah,
oh, right,
just
right.
calculate.
So I'm seeing something here though, because how do I? What do I do first? Do I subtract? Do I find this?
Remember,
square?
math is not taught in a box. So remember, we know about order of operations.
Right.
So you have L subtract N squared.
Okay.
What do you know that you're supposed to do?
All right.
First?
So I need to do N square.
Perfect.
And N square means N
multiplied by
N. All right. So let's see if we can see that.
So let's write that matrix representing N.
All right. So we have our matrix. So let's see how this multiplication is done.
Right.
All right.
And
so again, we have -1 times -1, which will give us +1. 3 times 0,
Excuse
0.
us.
-1 times 3, -3. 3 times 2 is 6.
Correct.
We move down to
Row 2.
row 2. And we're going again. 0 times -1, 0. 2 times 0,
0.
0. 0 times 3,
0.
and 2 times 2,
4.
4. Let's see if we can get an answer
So
here.
N square is 1304.
4. But we're not finished because they asked us to subtract, right?
That value from
L.
L.
And we would have learned subtraction a few lessons before.
Right.
So we're basically doing our regular thing. Just take our elements that are in the same positions and
From
subtract.
them,
And we would have
pretty
done
much.
this in previous lessons.
Right.
So
And
let's see what our result is.
2 -1 1 0.
All right, and so we are leaving this question on screen for our viewers. Be sure to work it out, submit your answers to Television Jamaica, and when we come back next week for math, you will find the answer to this question. So we're going to just quickly summarize. Please check the Facebook page. You will find the question there as well. And we will quickly summarize. So we can tell, Tom, if two matrices can be multiplied by each other by examining their order
Or dimension.
We can check the order of the matrices. We look at those values, the inner values, right? That's coming on screen, and they will tell us if they are compatible. And the outer values on screen will tell us the result of the order of the resulting matrices.
Correct.
We know that matrix multiplication is not commutative
unless
except
it is the identity matrix.
All right, and so we end here for today. That's all for today. We are now one step closer to understanding the multiplication of matrices. You can catch a repeat of today's lesson on JNN later at 5 p.m. and in Schools Not Out highlights on Saturday between 1 and 4 p.m. It will also be on video on demand on onespotmedia.com. Next up, we've got CSEC Information Technology with Leo Lewis.
Thank you for tuning in.
Thank you.